Hey everyone. So, have you ever been stuck trying to figure out how to securely share a common service? Something like DNS or Active Directory with a bunch of different isolated tenants inside your Cisco ACI fabric? It's a super common problem, right? Well, the answer is a really powerful feature called a shared L3Out. In this explainer, we're going to break down exactly how this thing works. Let's get right into it. So here's our game plan. We'll kick things off with what a shared L3Out actually is and why you'd even want to use one. Then we'll dive into the nitty-gritty, the key configuration settings that really make it all tick. After that, I'm going to walk you through a simple 3-step process to set one up. We'll look at a real-world tenant-to-tenant example, and then we'll wrap it all up with some key considerations and a quick summary. All right, first things first. Before we start clicking around and configuring anything, we really need to get our heads around the basic concept. So what is a shared L3Out, and what problem is it actually trying to solve for us in a multi-tenant ACI world?
The easiest way to think about a shared L3Out is to imagine it as your central hub for common services. See, instead of building a whole separate external connection for every single tenant that needs DNS or logging services, you just build one L3Out. And from there, you can selectively and securely leak access to those outside resources to any of your internal tenants, even if they're in totally separate, isolated VRFs. It's just a much more efficient and clean way to manage things.
So how does ACI actually pull this off? Well, the magic really comes down to 2 specific settings. You can think of them as scopes that you configure on the subnet within your L3Out's external EPG. Let's take a look at where you find these and, more importantly, what each one actually does. Okay, so this screenshot right here shows you the exact spot in the ACI GUI where the action happens. When you're defining a subnet for your external service, you'll see these 2 key sections. One is route control, and the other is external EPG classification. The little checkboxes we're about to talk about are right in there, and trust me, understanding what each one does separately is absolutely critical to making this work. And this slide really nails the whole separation of duties in ACI. On the left, you've got shared route control subnet. This is purely about networking. It's the plumbing. Checking this box is you telling ACI, hey, take this external route and stick it into the routing table of any VRF that needs it. It's all about reachability. Then on the right, you have shared security import subnet. This one is all about security. It's the bouncer at the door. It tells the consumer VRF which external EPG this traffic belongs to, so you can actually apply contracts to it. So one handles the path, the other handles the permission.
So you might be asking, why have 2 separate checkboxes? Well, the key word here is granularity, and this is where it gets really cool. Imagine your L3Out learns a huge summary route, something like a 10.0.0.0/8. You can use shared route control on that big /8 route just once to make that whole address space reachable in other VRFs. But then you could use shared security import on more specific chunks inside that range, like a 10.0.0.0/16 here and a 10.1.0.0/16 there, and apply totally different contracts to each one. It gives you this incredible flexibility to control access with some serious precision.
Okay, now that we've got the core components down, let's put it all together. The whole configuration can really be boiled down into a pretty straightforward 3-step process. Yep, it pretty much comes down to this. Step 1, you need a contract that can actually be seen and used across different tenants. So setting its scope to global is the typical way to go. Step 2, on the provider side, the L3Out side, you check that shared route control subnet box. That handles the routing. And step 3, you check the shared security import subnet box right next to it to handle the security policy mapping. That's the basic recipe right there. Theory is one thing, but let's see how this actually works in a real-world scenario. We're going to walk through a classic use case, one tenant providing a shared service to a completely different tenant. All right, let's take a look at this diagram. It's pretty straightforward. Over on the left, we have tenant 1. We'll call them our service provider. They own the L3Out connection to the outside world. And on the right, we've got tenant 2, our consumer. They have an application EPG that needs to get to that external service. So the goal here is to connect EPG2 in tenant 2 to that external route 10.10.10.0/8 that's coming in through tenant 1's L3Out. So let's zoom in on what tenant 1, the provider, has to do. This is where most of the setup happens. The administrator over there defines the external subnet 10.10.10.0/8, and then they check both of our magic boxes, shared route control subnet and shared security import subnet. They also create a contract. We can call it global contract, set its scope to global, and then they configure their L3Out EPG to provide that contract. Now, let's switch over to the consumer tenant 2. Their job is way simpler. The admin for tenant 2 just has to go to their own internal EPG, EPG2 in our picture, and tell it to consume that very same global contract that tenant 1 is providing. And because that contract scope is set to global, tenant 2 can see it and use it, no problem. It's a really elegant provider-consumer model. So let's do a quick-fire recap of the exact settings we just saw in that diagram. On the provider's L3Out EPG, for that 10.10.10.0/8 subnet, you need 3 things. You have to define it as an external subnet, and then you have to check both shared route control and shared security import. The contract needs a scope, like global, so it can actually cross between tenants. But there's one more critical piece of the puzzle on the consumer side that we need for the return traffic to work.
And this is a big one. You have to remember that communication is a two-way street, right? So tenant 2 can now reach the external service, but how does that external service talk back to tenant 2? The answer is this little checkbox advertised externally, which you find on the consumer's bridge domain subnet. Ticking this box is what tells ACI to leak the route for EPG2 back into tenant 1's VRF so it can be advertised out the L3 out. If you forget this step, you'll have one-way traffic, and your application just won't work.
Okay, so we've covered the what, the why, and the how. Let's bring it all home by summarizing the most important points and highlighting one absolutely critical best practice that you really can't afford to forget. All right, let's wrap this up. Key takeaway number 1, shared L3 outs are your go-to tool in ACI for centralizing and sharing external services. Number 2, the real power comes from separating route control and security policy, which gives you that fine-grained control. And 3, the process is simple. A shared contract, and 2 key checkboxes on the provider's L3 out. But please, and I can't stress this enough, pay attention to this warning. Never, ever leak a route into a consumer VRF if that same subnet already exists inside that VRF. It will cause a routing conflict and some very strange, unpredictable behavior. Always plan your IP addressing carefully.
And that pretty much covers it. The real power of this feature, of course, is what you can do with it. So I'll just leave you with this question to chew on. When you look at your own network, what services are you deploying again and again for different apps or tenants? Could you use this shared L3 out pattern to centralize them, make your life easier, and build a much more efficient and scalable fabric? Something to think about. Thanks for tuning in.